Hey guys, let's take a look at the last question on AP Chemistry 2021 first one's questions. Number 7. So, number 7, the question is asking, calculate the density of the O2 gas at the condition they provided, which is the volume is around 8 liters, the pressure is 1 atm, and temperature is at 25 degrees Celsius. They also provide you with the number of moles of the O2 gases. So, I mean, it sounds a really easy question, but I think this might be one of the questions where it's a little tricky. So density is equal to mass over volume. Okay, that's what density is equal to. So they want you to calculate density of the O2 gases. So I think there's two different ways you can solve this question because they did mention that the container contains about 0.325 moles of the O2 gases. So we get the mass from that information? Yes, we can. Okay, so we have a 0.325 mole of the O2 gases, and so 1 mole of the O2 equals to around 32 grams of the O2. So this will get you the mass of the O2 gas, and divided by the volume, which they provided to as 7.95 liters. Okay. So if you solve this, you probably will get around like 1.31 grams per liter, somewhere around there. Is this the best way to solve this question? Perhaps, but is there a better equation you can utilize? Yes, there is. So so what if they haven't provided you with number of moles here? Can you still get density? Yes, you can. So this is how I used to teach my students, guys. So I would start with PVRT equation, okay? And when you look at the equation, then how do I get a density? Because density is equal to mass over volume, and there's no mass here, right? But now we know that, guys, number of mole is equal to mass over the molar mass. So now we have a mass in there. That's the mass that we need right there. So we have mass and we have volume. So can we have density in the equation for the ideal gas equation? Yes, we can. So pressure times volume is equal to mass of the gas divided by the molar mass times RT. Okay. So now we got the mass and volume. Okay. So now we just have to put it in a format that we want to have a density. As you can see, guys, you can cross multiply some variables here. What you can get here is right here, pressure times molar mass is equal to mass times RT. And over volume, volume is here. That's density. Okay. I just swapped out the molar mass and volume. And now I'm going to divide by the RT on both sides. Okay. Cancels out. That's the equation. So this becomes the equation, guys, for a density of an ideal gas, which equals to pressure times the molar mass of the gas divided by RT. R is the gas constant, and temperature. So now, if you plug in the values as what they provided to you, a pressure, which will be 1 atm, molar mass of the O2 gas is 32, divided by 0.0821 for the value of R, temperature is 298. So if you solve this, that'll be density, which is around same answer, 1.31 grams per liter. That'll be the density. So I always teach my students, make sure you know how to get this equation for the ideal gas density, okay? And this equation will help you to understand better how to solve part B and C and such. So part B, attempting to change density of the O2 gas, student opens the valve on the cylinder, okay, pushes down the piston, pushes down, right? And then release some of the gas on the O2 gas, some of the O2 gas releases. And the question is asking, the temperature of the gas remains constant, temperature doesn't change, okay? They're asking what happens to the density. So from this equation, for the ideal gas law that we converted to the density, if temperature is not changing as what the question states, molar mass of the O2 gas is not changing. It stays at 32 grams per liter, okay, or grams per mole. So that's not changing, right? So the density of a gas depends on the pressure. The question did not state the pressure is changing within the container. So that's an assumption you have to make. So when you press it down, some of the gas leaves, okay, will the density change? It depends on the pressure. So if I'm the student writing out a response, giving this equation, okay, when you press it down and some of the gas goes down, goes out, you close the valve, and by doing that process, if the pressure doesn't change, then density should be the same for the O2 gas. That'll be my response, guys. But if the pressure is not same as what it was before, 1 atm, then density will change. That'll be part B, guys. Okay. Part C. Question is asking, the student tries to change the density of the O2 gas by cooling the cylinder to negative 55 degrees Celsius, which causes the volume of the gas to decrease. Okay. Using the principle of kinetic molecular theory, explain why the volume of the O2 decreases when the temperature decreases to negative 55. So they want you to explain this in KMT, kinetic molecular theory. So what are some of the KMTs you have to know? So the first one is ideal gases are what? They are actually what? Yeah, they do not have any intermolecular force of attractions. Okay, so by not having IMF, they cannot turn into a liquid or even solid. Okay, unless temperature becomes 0 Kelvin, right? So which means what? You can lower temperature all you want, but still it'd be a gas because there's no IMF. So other part is what, guys? Other KMT is the gas particles do not have any volume. Okay, the particle themselves. So ideal gas perspective, the gas volume is equal to the container volume. If the container is 1 liter, gas volume is 1 liter. If the container is 2 liters, then the gas volume is 2 liters. So it's truly what? The gas volume is equal to, for the ideal gas volume, is equal to the container volume because what? It's the little tiny gas particles do not have any volume at all. And third one is what, guys? Something we call elastic collision. So AP Chem, they really do not ask about the elastic collision because that is more on the physics side. Okay, so you have to know it, but they don't want to talk about it too much on the test. The next one is what? It's basically where they mention about the temperature and the average kinetic energy of the particles. That's one of the KMT. So the KMT states, as you guys all know, temperature is proportional, okay, or you can say equal to. So temperature is proportional to average kinetic energy. So you can say there's the equation of what? Average kinetic energy of the particle is equal to 3/2 times RT. That's the equation, okay? Where if temperature goes up, this goes up. Temperature goes down, kinetic energy goes down, okay? And now they're saying temperature is going down, which means what? Kinetic energy is going down. If kinetic energy goes down, what happens, guys? The gas particles are moving at a slower speed, okay? And you have to understand, okay? So how does that have an impact on the volume going down? So the understanding is how the gas particle exerts pressure. You have a movable piston here, okay? So the gas particles exert pressure. So what is pressure? Pressure of a gas is equal to, the pressure overall, the equation, right, is equal to force over area. That's what pressure equation is, force over area, okay? And now, as the gas particles collide onto the wall of the container, they bounce back, right? They bounce off of the wall. That's how what? That's where the force is being exerted, and that's how the pressure of the gas is being exerted. But now, if you think about it, when temperature goes down, kinetic energy goes down, which means what? They ended up slower speed. Since they move slower speed, they'll hit the wall with less force, which means what? The pressure of the container, pressure of the gas, will be less because gas will hit the wall with the lower speed. Okay? So now, as the pressure of the gas decreases, and now the pressure of the outside seems to be around 1 atm, right? Then what happens? Because outside pressure is greater, what does it mean, guys? They are pushing or applying a greater force, like a greater pressure on the outside, which will try to move the piston down. So it's like a pushing war if you think about it, right? So the force that the gas exerts on the inside the container becomes less, and outside the pressure becomes a greater value. They're gonna push this down. The volume of the gas will start to decrease. I think that's how Kyle Asbury wants to explain why the volume goes down based on KMT for part C. And part D, the question is asking, the student further cools the cylinder to negative 180 degrees Celsius and observed that the measure of the volume of the O2 is substantially smaller. So substantial means it's not from like 1 liter to like like zero point 0.8. Substantially means what? It went down a lot. Then the volume of the calculated using the ideal gas law. So they're doing the PVNRT. The pressure went down a lot more than expected, and assume that the equipment is functioning properly. Explain why the measure of the O2 gas is smaller. So the boiling point is negative 183 degrees Celsius, and temperature is below that, which means what? Which means, in my understanding, some of the gas can potentially have converted into, or most of all, probably have converted into liquids. So based on heating curve, this heating curve. So based on what I can tell, based on what information provided from the question, the temperature which the boiling occurs, this is a boiling point, right? Temperature which this occurs, guys, is what? Negative 183 degrees Celsius. Okay, but they're at a lower temperature than that, which is around here. So this is a solid, that's a liquid, this is a gas, which means a lot of them probably have converted from gas to liquids. Okay, so we all know liquids have much lower volume compared to the gases. So probably by lowering temperature, condensation has occurred, okay, where a gas converted into a liquid, which substantially lowered the volume of the substance from, whatever the gas volume was to the liquid volume. And that'll be the answer, guys, for part D. And that concludes, guys, the review for 2021 AP Chemistry Review. So I personally think, except for a couple parts on number 1 and also on number 7, I think the questions were relatively easy compared to the other years from 2020 or 2020. We didn't really have a valid questions, but 2019 and 2018. So I think the questions are. I didn't see any challenging questions on 2021. So hope you guys did well. And those of you who are studying for the exam for tomorrow or even I think early June, hope this helps. I'll talk to you guys later.